Hello everyone, my name is Yerdoulet and I am from Group SEA 2104, and this is defense for my report on assignment 1 and 2 covering modules from 1 to 7. So this is module 1. Module title is Networking Today, and objective of this module is explaining the advances in modern networking technologies. So we're gonna cover many topics which are networks affect our lives, network components, network representation and topologies, common types of networks, internet connections, reliable networks, network trends, network security, the IT professional. And first of all, as a student, we have to download and install Packet Tracer because Packet Tracer is the app that we're gonna use to prepare for a certification exam. And so why do we need to install this Packet Tracer? Because commonly students use it to practice and learn networking courses and examine the impact of adding new technologies into existing network designs. So to obtain and install this Cisco Packet Tracer, we're gonna follow up these steps, which are like step 1 is to log into your Cisco Network Academy in Learning page, and then select the resources, then select download Packet Tracer. Then we have to select the version of Packet Tracer you require, and then save the file to your computer, then launch, and you're gonna install the program. So then we have to get started with Cisco Packet Tracer. After the installation, we have to get used to tools that this program provides, and Packet Tracer provides 3 main menus. You can add devices and connect them via cables and wireless. You can select, delete, inspect, label, and group components with your network. And you can manage your network by opening an existing sample network. So if you have already used any program such as a word processor or spreadsheet, and you familiar with these file menu commands, then it's gonna be the same here. The open, save, and save as and exit commands work as they would do in those programs. So after the getting used to Cisco Packet Tracer, in following course we're gonna use this to learn and practice our skills. So networking affects our lives. Networks have become an integral part of our life, impacting the way we communicate, work, and access information. The Cisco Introduction to Networks course highlights the various ways in which networks affect our lives. So one of the main ways in which networks affect our lives is through communication. Networks enable us to communicate with people across the world through various means such as email, instant messaging, video conferencing, and social media, of course. And this has made it possible for people to work remotely, collaborate on projects, and build relationships with people in different countries and different parts of the world. In addition to that, networks have revolutionized the way we access information. The internet, in which is essentially a global network of networks, provide us with access to an endless amount of information on any subject. This has transformed the way we learn and conduct research and make decisions, because we can compare the information that we have in your own country and compare the information with from different countries, and it really helps us to understand better and research it more truly. However, of course, networks also bring with some security concerns. As more devices become connected to networks, the risk of cyber attacks increases. Networks must be secured to prevent unauthorized access, data theft, and malicious activities. So, concluding this, I'm gonna say that networks have a profound impact on our lives, and from the way we communicate and access information to the way we conduct businesses, understanding how network works and how to secure them is becoming increasingly important in today's digital age. So, networking components. Networking components are physical and logical building blocks of the computer network. The Cisco Introduction to Network course provides us with an overview of the various network components. The first component of a network is end device, such as computer, server, or router. These devices are connected to the network through network interface cards, NICs, which allow them to send and receive data. And routers are another critical network component. Routers are responsible for forwarding data packages between different networks, such as between a home network and the internet. Routers can be used to implement security measures, such as firewalls, which help us to protect the network from unauthorized access or attacks. And also we have cables and connectors that are also important network component. Ethernet cables, for example, are used to connect devices to the network. Other types of cables, such as fiber optic cables, can be used to transmit data over long distances and also at higher speeds. So we have different types of network cables, and network switches also are another important component of a network. Switches are used to connect multiple devices on a network, allowing them to communicate with one another. Switches can also be the segment network into smaller subnetworks, which can help improve network performance and security. Finally, network protocols are essential network component because protocols are a set of rules and standards that govern how data is transmitted. An example of it will be TCP/IP, which is used for communication over the internet, and simple mail transfer protocol, for example, which is used to send emails. And then there are network representation and topologies. So physical topology diagrams illustrate the physical location of intermediary device and cables installation as shown in the figure here. You can see that the room in which these devices are located are labeled in this physical topology. And then we have logical topology diagrams. Logical topology diagrams illustrate devices, ports, and addressing scheme of the network. You can see that which end devices are connected to which intermediate device and what media is being used. So we have common types of networks. They come in all sizes. They range from simple networks consisting of only 2 computers to networks connecting multiple devices. Small home networks connect few computers to each other and the internet. Then we have small office or home office, enables computer within a home or remote office to connect to a corporate network. Medium to large networks, many locations with hundreds and thousands of interconnected computers. And then in the end we have worldwide networks connected like hundreds of millions of computers around the world, such as the internet. So we have LANs and WANs. So what is the difference? LAN is a network infrastructure that spans a small geographic area. LANs have like specific characteristics. For example, LANs interconnect end devices in a limited area, such as home, school, office buildings, or campus. A LAN is usually administered by a single organization or individual. LANs provide high-speed bandwidth to an internet end device and intermediary device. And then WANs is network infrastructure that spans wide geographical area, typically managed by a service provider. For example, Kazakh Telecom in Kazakhstan, right? And they have also characteristics. WANs are interconnected LANs over the wide geographical area, such as between cities, states, provinces, countries, and continents. WANs are usually administered by multiple service providers. WANs typically provide slower speed links between LANs because they use also wireless, and the distance also have effect on the slowing the internet speed. So there are two other terms that are similar to term internet, which are intranet and extranet. So what are the main? Intranet is a term often used to refer a private connection of LANs and WANs that belongs to an organization, and intranet is designed to be accessible only by an organization, members, employees, and other with authorization. Extranet, on the other hand, they provide secure and safe access to individuals who work for a different organization but require access to an organization's data. Here are some examples of extranet. A company that is providing access to outside suppliers and contractors. A hospital that is providing booking system to doctors so they can make appointments for their patients. Local home office of education that is providing budget and personnel information to the school in its district. Internet connections. Home and small office internet connections. So there are cable, typically offered by cable television service providers. The internet data signal transmits on the same cable that delivers cable television. DSL, which stands for digital subscriber lines, also provided high bandwidth, high availability, and always on connection to the internet. Cellular is an internet access used a cell phone network to connect. And satellite, the availability of satellite internet access is a benefit in those areas that would otherwise have no internet connectivity at all. Dial-up telephone, an inexpensive option that uses any phone line in a modem. The low bandwidth provided by a dial-up modem connection is not sufficient for large data transfer, although it is useful for mobile access while traveling. Also, we have business internet connections. So there are four. Dedicated leased line. Leased lines are reserved circuits within the service provider's network that connect geographically separated offices for private voice and data networking. Metro Ethernet. This is sometimes known as Ethernet WAN. In this module, we will refer to as Metro Ethernet because we have lots of terms that we're going to use, and that's why. And we also have Business DSL. Business DSL is available in various formats. A popular choice is Symmetric Digital Subscriber Line, which is a similar version to a consumer version. Also, we have satellite. Satellite service can provide a connection when a wired solution is not available. So converged networks. Today, the separate data, telephone and video networks converge, unlike dedicated networks. Converged networks are capable of delivering data, voice and video between many different types of devices over the same network infrastructure. This network infrastructure uses the same set of rules, agreements and implementation standards. So converged data networks carry multiple services on one network. Reliable networks. So reliable networks are essential for ensuring the data transmitted accurately and efficiently across the network. So one of the main factors to contribute that is network reliability, which is redundancy. Redundancy involves duplicating critical components of the network so that if one component fails, the redundant component can take over without disrupting network operations. For example, network can have redundant power supplies, network cables, network switches to ensure that if any of these components fail, the network can continue to operate. Another critical aspect of reliable network is fault tolerance. Fault tolerance refers to the ability of a network to continue operating even in the event of a component failure. This can be achieved through the use of load balancing and failover mechanisms, which ensure that network traffic is automatically routed around any failed components. Network monitoring is also essential for maintaining network reliability. Network administration can use various tools and techniques to monitor network performance, identify potential programs, and take corrective actions before they cause network downtime or performance issues. So, in conclusion, reliable networks are crucial for ensuring that data is transmitted accurately and efficiently across the network. Implementing redundancy, fault tolerance, network monitoring, and security measures can help ensure that a network operates reliable and minimize the risk of downtime of performance issues. So with network trends. Network trends are constantly evolving as technology advances and new innovations emerge. The Cisco Introduction to Network course highlights some key network trends that are shaping the future of networking. They are BYOD, which stands for Bring Your Own Device, online collaboration and cloud computing and smart home technologies, etc. Bring your own device. The concept of any device for any content in any manner is a major global trend that requires significant changes to the way we use devices and safely connect them to network. This is called bring your own device. And we also have online collaboration. Individuals that want to connect to the network not only for access to data applications but also to collaborate with one another. Collaboration is defined as the act of working with another or others on a joint project. We also have cloud computing, where people are storing and using services from different parts of the world they are using the cloud computers to use the services that they provide, and storing information, getting information is being easier help. Network security. Network security is a critical aspect of any computer network, and there are several common external threats to networks. There are viruses, Trojan horses, spyware and adware, zero-day attacks, threat actor attacks, denial of service attacks, and identity theft. So there are many external threats to networks, so they require security solutions. So there are basically two main basic security components for home and small office network, which are antivirus and anti-spyware. These applications will help you to protect end devices from becoming infected with malicious software. And we also have firewall filtering. Firewall filtering blocks unauthorized access into and out of the network. This may be included a host-based firewall system that prevents unauthorized access to the end device. The IT professional, CCNA, the role and skills that required of network engineers are evolving and are more vital than ever. The Cisco Certified Network Associate (CCNA) certification demonstrates that you have a knowledge and foundation technologies that ensures you stay relevant with skills set needed for an adoption of next generation technologies. Okay, now we're gonna move on to module 2. The module title is Basic Switch and End Device Configuration. Objective is to implement initial settings including passwords, IP addressing, and default gateway parameters on a network switch and end devices. So there are many topics and we're gonna go through them. First, Cisco IOS access. So operating systems, all end devices and network devices require an operating system. As shown in the figure, the proportion of the OS that interacts directly with the computer hardware is known as the kernel. The proportion that interfaces with applications and the user is known as the shell. The user can interact with the shell using command line interface, CLI, or graphical user interface, GUI. GUI such as Windows, macOS, Linux KDE, Apple iOS, or Android allows the user to interact with the system using an environment of graphical icons, menus, and windows. The GUI example is more user-friendly and requires less knowledge of the underlying command structure that controls the system. That's the reason most users rely on graphical user interface. Purpose of an OS. Network operating systems are similar to a PC operating system. Through a GUI, a PC operating system enables a user to do the following: use a mouse to make selections and run programs, enter text and text-based commands, view output on a monitor. CLI-based network operating systems such as Cisco IOS on a switch or router enables network technician to do the following: use a keyboard to run CLI-based network programs, use a keyboard to enter text and text-based commands, view output on a monitor. iOS navigation, primary command modes. As a security feature, the Cisco IOS software separates management access into the following two command modes: user exec mode and privileged exec mode. User exec mode allows access to only limited number of basic monitoring commands. It is often referred to as view only mode. Privileged exec mode, on the other hand, allows access to all the commands and features. The user can use any monitoring commands and execute confirmation and management commands easily. The command structure, basic iOS command structure. So Cisco iOS device supports many commands. Each iOS command has a specific format or syntax and can be executed in an appropriate mode. The general syntax for a command shown in the figure is the command followed by an appropriate keywords and arguments. So command syntax check is identified in the table. Boldface text indicates commands and keywords that are entered as shown. Italic text indicates an argument for which the user provides the value. The following examples demonstrate that conventions use the document and use iOS commands. Ping IP address, the command is ping and the user-defined argument is IP address. Hotkeys and shortcuts. The iOS CLI provides hotkeys and shortcuts that make configuring, monitoring, and troubleshooting much easier. We have safe configuration. To do that, we need configuration files. There are two system files that store device configuration: startup config and running config. The show running config privileged exec mode command is used to view the running config as shown in the example below. The command will list the complete configuration currently stored in RAM. Ports and addresses. IP addresses, the use of them is primary means of enabling devices to locate one another and establish end-to-end communication on the internet. Examples of end device include computers, network printers, security cameras, and etc. For that, we need interfaces and ports. Networks communication depend on end user devices. Interfaces, networking device interfaces, and the cables that connect them. Cisco iOS Layer 2 switches have physical ports for device to connect. These ports do not support Layer 3 IP addresses, therefore switches have one or more switch virtual interfaces. These are virtual interfaces because there is no physical hardware on the device associated with it. That's why configuring IP addresses manually. To do that, we go to IPv4 address on the Windows host, open Control Panel, Network Sharing Center, then go to Change Adapter Settings and choose the adapter. Next, we're gonna right click and select Properties to display local area connection properties. So in automatic IP address configuration for end devices, we're gonna do the same as before, but we're gonna select obtain an IP address automatically and obtain DNS server address automatically. Your PC will search out a DHCP server and be assigned the address settings necessary to communicate on the network. So we're gonna move to module 3. The module 3 title is Protocols and Models. Objective of the model is explaining how network protocols enable network devices to access local and remote network resources. So there are many topics and we're gonna go through them. First of all, rules, communication fundamentals. People exchange ideas using many different communication methods. However, all communication methods have the following three elements in common: message source, sender or person that is talking, and then message destination or receiver. The destination receives the message and interprets it in his or her mind. And then channel. This consists of the media that provides pathway over which the message travels from source to destination. And then rule establishment. Protocols must account for the following requirements to successfully deliver a message that is understood by the receiver: an identified sender and receiver, common language and the grammar, speed and timing of delivery, confirmation or acknowledgement requirements. Network protocol requirements. The networks The protocols that are used in the network communication share many of these fundamental traits. In addition to identifying the source and destination, computer and network protocols define the details of how a message is transmitted across a network. Common computer protocols include the following requirements: message encoding, message formatting and encapsulation, message size, message timing, message delivery options. Protocols. Network protocols define a common format and a set of rules for exchanging messages between devices. Protocols are implemented by end device and intermediary devices in software, hardware, or both. Each network protocol has its own function, format, and rules for communication. So we have many types of protocols like network communication protocols, network security protocols, routing protocols, and service discovery protocols. A message sent over a computer network typically requires the use of several protocols, each one with its own functions and format. Computers and network devices use agreed upon protocols to communicate, and these are lists of the functions of these protocols: addressing, reliability, flow control, sequencing, error detection, application interface. Protocol suites. A protocol suite is a group of interrelated protocols necessary to perform a communication function. One of the best ways to visualize how the protocol within a suite interact is to view the interaction as a stack. A protocol stack shows how the individual protocols within a suite are implemented. The protocols are viewed in terms of layers, with each higher level serves depending on the functionality defined by the protocol shown in the lower levels. Standards organizations. Open standards encourage interoperability, competition, and innovation. They also guarantee that the product of no single company can monopolize the market or have an unfair advantage over its competition. Standards organizations are usually vendor nature, non-profit organizations established to develop and promote the concept of open standards. Internet standards. Other standards organizations have responsibilities for promoting and creating the electronic and communication standards used to deliver the IP packets as an electronic signals over wired and wireless medium. These standard organizations include the following: IEEE, pronounced IEEE, Electronic Industries Alliance, Telecommunications Industry Association, International Telecommunications Union, Telecommunications Standard Sector. Then we're gonna talk about reference models, the benefits of using a layered model, complex concepts such as how a network operates can be difficult to explain and understand. For this reason, a layered model is used to modularize the operations of a network into manageable layers. So the OSI reference model, there are 7 layers: application, presentation, session, transport, network, data link, and physical. The TCP/IP protocol model, used by 4 layers: network access, internet, transport, and application. Data encapsulation. Segmenting messages is the process of dividing a stream of data into smaller units for transmissions over the network. It is necessary because data networks use the TCP/IP protocol муха жайғыш. This leads to segmenting messages having two primary benefits. Increases speed because a large data stream is segmented into packets. A large amount of data can be sent over the network without tying up a communication link. Increases efficiency. If a single segment fails to reach its destination due to a failure in a network or network congestion, only the segment needs to be retransmitted instead of resending the entire data stream. Sequencing. TCP is responsible for sequencing the individual segments. It stands for getting the order of the packets that were segmented before. For example, if you have 100 envelopes, for example, and they can be sequenced right from 1 to 100, and all the envelopes will be in correct place. Encapsulation and de-encapsulation. When messages are being sent on the network, the encapsulation process works from top to bottom. At each layer, the upper layer information is considered data within the encapsulated protocol. De-encapsulation, on the other hand, is the process used by the receiving device to remove one or more of the protocol's headers. The data is de-encapsulated as it moves up the stack towards the end user application. Data access. Addresses, the network and data link layers are responsible for delivering the data from source device to a destination device. Protocols at both layers contain a source and destination address, but their addresses have different purposes. Network layer source and destination addresses, they are responsible for delivering the IP packet from the original source to the final destination, which may be on the same network or a remote network. Data link layer source and destination addresses responsible for delivering the data link frame from one network interface card NIC to another NIC on the same network. Layer 3 logical address is an IP address is a network layer or layer 3 logical address used to deliver IP packet from the original source to the final destination. It contains two IP addresses, source IP address and destination IP address. Devices on the same network have the similar source IPv4 address and destination IPv4 address. Data link addresses, data link layer 2 physical address has a different role. Purpose of the data link address is to deliver data link frame from one network interface to another network interface on the same network. Now we're gonna go to model 4, which is physical layer, and we're gonna explain how physical layer protocols, services, and network media support communications across data networks. So, the purpose of the physical layer. The physical connection is the main purpose, whether connecting to a local printer into the home or website in another country. Before any network communication can occur, a physical connection to a local network must be established. A physical connection can be wired connection to cable or wireless connection using radio waves. Network interface cards connect a device to the network. Ethernet NICs are used for wired connection, whereas wireless local area network WLANs NIC are used for wireless, and end user device may include one or both types of NICs. A network printer, for example, may only have Ethernet. therefore must connect to the network using Ethernet cable only. The other devices such as tablets, smartphones might only contain VLAN NIC and must use a wireless connection only. Physical layer, the OSI physical layer provides the means to transport the bits that make up a data link layer from across the network media. This layer accepts a complete frame from the data link layer and encodes it as a series of signals that are transmitted to a local media. Physical layer characteristics. There are many physical layer standards and there are many international and national organizations that govern these physical layer standards, which are International Organization for Standardization, ISO, Telecommunication Industry Association, TIA, International Telecommunication Union, ITU, and etc. Physical components. There are many components that contains in the physical layer. There are, which is electronic hardware devices, media and other connectors that transmit the signals and represent the bits. Hardware components such as NICs, interfaces and connectors, cable materials and cable designs are all specified in standard associated with the physical layer. The various ports and interfaces on a Cisco 1941 router are also examples of physical components with specific connectors and pinouts resulting from standards. Encoding or line encoding is a method of converting a stream of data bits into predefined code. Codes are groupings of bits used to provide predictable pattern that can be recognized by both the sender and the receiver. In other words, encoding is a method of pattern used to represent digital information. The physical layer must generate the electrical, optical, or wireless signals that represents the 1 and 0 on the media. The way that bits are represented is called signaling method. The physical layer standards must define what types of signal represent a 1 and what type of signal represents a 0. This can be as simple as a change in the level of electrical signal or optical pulse. For example, long pulse might represent 1, whereas short pulse might represent 0. There are bandwidths in bits per second. For example, bits per second is the abbreviation BPS, fundamental unit of bandwidth. And then we have kilobits per second, megabits per second, gigabits per second, and terabits per second. Copper cabling. Copper cabling is used in physical layer, and characteristics of copper cabling. Data is transmitted on the copper cables as electrical pulses. A detector in network interface of a destination device must receive a signal that can be successfully decoded to match the signal sent. However, the farther the signal travels, the more it deteriorates. This is referred to as signal attenuation. For this reason, all copper media must follow strict distance limitations as specified by the guiding standards. The timing and the voltage values of the electrical pulses are also susceptible to interference from two sources: electromagnetic interference, radio frequency interference, or crosstalk. There are three main types of copper media used in networking. There are unshielded twist pair, UTP cable, shielded twist pair, STP cable, which is like a little bit better, coaxial cable. So the difference between unshielded twisted pair and the shielded twisted pair is that shielded twisted pair provides better noise protection than UTP cabling. However, compared to UTP, STP cable is significantly more expensive. So they have their own places of using, I would say. Coaxial cable, on the other hand, is gets its name from the fact that there are two conductors that share the same axis. That's why it's like coaxial cable. It consists of a copper conductor that is used to transmit the electrical signals, a layer of flexible plastic insulation, and then the insulating material is surrounded in a woven copper braid or metallic foil that acts as a second wire. The entire cable is covered with a cable jacket to prevent minor physical damage. Now we're gonna talk about cabling. Cabling doesn't use UTP cabling. UTP cable doesn't use shielding to encounter the effects of EMI and REFI. Instead, cable designers have discovered other ways that they can limit the negative effect of crosstalk, which is cancellation and varying the number of twists per wire pair. UTP cabling standards and connectors. There are many categories of UTP cable. Category 3 was originally used for voice communication over voice lines, but later used for data transmission. Then we have Category 5 and 5E that is used for data transmission also, and Category 5 supports 100 megabits per second, and Category 5E supports almost 1 gigabit per second. Category 6 has an added separator between each wire pair to support higher speeds. That's why it supports up to 10 gigabits per second, as well as Category 7, which supports 10 gigabits per second too. And the last one is Category 8 that supports 40 gigabits per second. UTP cable is usually terminated with RJ45 connector. Cable types and standards are Ethernet straight through, Ethernet crossover, and rollover. Now we're gonna talk about fiber optic cabling. Fiber optic cabling is a different way of cabling from the copper cabling, because fiber optic cables are used to transmit data over long distances and higher bandwidth than any other networking media. Unlike copper wires, fiber optic cable can transmit signals with less attenuation and is completely immune to EMI and RFI, and it's commonly used to interconnect network devices. As an analogy, consider the empty paper towel roll with the inside coated like a mirror. It is 1,000 meters in length, and a smaller laser points is used to send Morse code signals at the speed of the light. So that's how fiber optic cables works. So there are broadly classified into two types, which is single mode fiber, SMF, and multi-mode fiber, MMF. SMF consists of a very small core and use expensive laser technology to send a single ray of light, whereas MMF consists of a larger core and uses LED emitters to send light pulses. Specifically, light from the LED enters the multi-mode fiber at different angles, so it provides bandwidth up to 10 gigabits over the link lengths up to 550 meters. Wireless media provide the greatest mobility options of all the media, and the number of wireless enabled devices continues to increase. These are some limitations of wireless, which is coverage area. Of course, wireless data communication technologies work well in open environment. However, certain constructions materials used in buildings and structures and the local terrain will limit the effective coverage. Also, interference. Wireless is susceptible to interference and can be disrupted by such common devices as household cordless phones, etc. Security, also the big aspect of wireless connection, because wireless communication coverage requires no access to a physical strand of media. Therefore, devices and users not authorized for an access to another network can gain access to the transmission. Also, shared medium. VLANs operate in half duplex, which means only one device can send or receive at a time. So wireless medium is shared amongst all wireless users. Now we're gonna go to Module 5. Module 5 title is Number Systems, and the objective is to calculate numbers between decimal, binary, and hexadecimal systems. So first of all, we're going to talk about binary number systems. So IPv4 addresses begin as a binary series of only ones and zeros. They are difficult to manage, so that's why network administration must convert them to decimal, so we can make it much easier for us humans, because binary is a numbering system that consists of only zeros and ones, called bits. In contrast, the decimal numbers consist of 10 digits consisting from 0 to 9, and binary is important for us to understand because hosts, servers, and network devices use binary addressing. Learning to convert binary to decimal requires an understanding of a positional notation. So positional notation means that a digit represents different values depending on the position the digit occupies in the sequence of numbers. So to convert a binary IPv4 to its dotted decimal equivalent, we're gonna have to divide the IPv4 address into 4 8-bit octets. So then we're gonna next apply the binary positional value to its first octet binary number and calculate accordingly. So it is also necessary to understand how to convert dotted decimal IPv4 address to binary. A useful tool is binary positional value also. Now we're gonna talk about hexadecimal number system. Just as decimal system, hexadecimal is a base of 16 systems. The base 16 number system uses the digits 0 to 9 and the letters A to F. The figures shown in the equivalent decimal and hexadecimal values for binary in the below here, from 0 to 9 and then from A to F. Converting decimal numbers to hexadecimal values is straightforward with following these steps. First, we're gonna convert the decimal number to 8-bit binary strings, and then we're gonna divide the binary strings in groups of 4 starting from rightmost position. Then we're gonna convert each 4 binary numbers into their equivalent hexadecimal digit. And converting hexadecimal numbers to decimal values is also straightforward, follows the steps listed underneath it. So we're gonna convert the hexadecimal number 4 to 4-bit binary strings, and then we're gonna create 8-bit binary grouping starting from the rightmost position, and then we're gonna convert each 8-bit binary grouping into the equivalent decimal digits. So now we're gonna go to module 6, data link layer, and objective of this module is to explain how media access control in the data link layer supports communication across networks. So the data link layer of the OSI model, layer 2, prepares network data for a physical network. The data link layer is responsible for network interface card to network interface card communications, and the data link layer does many things, which are enabling upper layers to access the media. It accepts data, usual layer 3 packets, and encapsulates them into layer 2 frames. Controls how data is placed and receives on the media, and also exchanges frames between endpoints of the network of media. LAN-MAN data link layer consists of the two sublayers: logical link control, LLC. This is like a IEEE sublayer communications between the network software at the upper layer and the device hardware at the lower levels. And also media access control, MAC, implements this sublayer in hardware. It is responsible for data encapsulation and media access control. Engineering organizations that define open standards and protocols that apply to the network access layer. There are many, but Institute of Electrical and Electronics Engineering, International Telecommunication Union, International Organization for Standardization, and also American National Standards Institute. So now we're gonna talk about topologies. So there are physical and logical topologies. The topology of a network is arrangement or relationship of a network devices and interconnections between them. So there are two types, physical and logical. So physical identifies the physical connections and how end devices, intermediary devices, are interconnected with each other. The topology may also include specific device locations such as room number or location on the equipment rack, whereas logical topology refers to the way a network transfers frames from one node to the next. This topology identifies virtual connections using devices interfaces and layer 3 IP addressing schemes. So WAN topologies, point-to-point WAN topology is the simplest and the most common WAN topology. It consists of permanent link between two endpoints. By endpoints, we mean PCs. Hub and spoke is a one version of the star topology, which is central site interconnection, branch sites through the use of the point-to-point links. And then mesh topology provides high availability but requires that every end system is interconnected to every other system. So now we're gonna talk about LAN topologies, which is early Ethernet and legacy token ring LAN topologies. Included two other types of topologies, which is bus. All end systems are chained to each other and terminated in some form on each end. And then ring topology, end systems are connected to their respective neighbor, forming a ring. The ring doesn't need to be terminated, unlike in the bus topology. So now we're gonna talk about data link frame. Data link protocol is responsible for NIC-to-NIC communication between the same network. Although there are many different data link layer protocols that describes data link layer frames. Each frame has three basic parts, which are header, data, and trailer. Framing breaks the stream into decipherable groupings with control information inserted the header and trailer as values in different fields. This format gives the physical signals a structure that are both recognized nodes and decodes into packages at the destination. The generic frame fields are shown in this figure here. Not only all protocols include all these fields, the standard for a specific data link protocol define the actual frame format. Now we're gonna move on to Module 7, Ethernet switching, and module objective is to explain how Ethernet operates in a switched network. Ethernet frame. This module starts with the discussion of Ethernet technology, including an explanation of MAC sublayer and Ethernet frame fields. So Ethernet is one of the two LAN technologies used today, with the other being wireless LANs, VLANs, and Ethernet uses wired communications, including twisted pair, fiber optic links, and coaxial cables. And Ethernet operates in the data link layer and the physical link layer. It is a family of networking technologies defined in the IEEE and standards. So Ethernet supports data bandwidth of the following, like 10 megabits per second, 100 megabits, up to 100 gigabits per second. The minimum Ethernet frame size is 64 bytes and expected maximum is 1518 bytes. This includes all bytes from the destination MAC address field through the frame check sequence. The preamble field is not included when describing the size of the frame. Ethernet MAC address. An Ethernet MAC address consists of 48 binary value. Hexadecimal is used to identify an Ethernet address because a single hexadecimal digit represents 4 binary bits. Therefore, a 48-bit Ethernet MAC address can be expressed using only 12 hexadecimal values. So in Ethernet LAN, every network device is connected at the same shared media. The MAC address is used to identify the physical source destination device, NICs, on the local network segment. So MAC addressing provides a method for device identification at the data link layer of the OSI model. So an Ethernet MAC address is a 48-bit address expressing only 12 hexadecimal digits as shown in the figure below. Because a byte equals to 8 bits, we can also say that MAC address is 6 bytes in length. When the computer boots up, the NIC copies its MAC address from ROM to RAM. When the device is forwarding a message to an Ethernet network, the Ethernet header includes source of the MAC address and then destination of the MAC address. So source of the MAC address is the MAC address of the source device, and the destination MAC address is the MAC address of the destination device NIC. Also, we have unicast MAC address, which is a unicast MAC address is the unique address that is used when a frame is sent from a single transmitting device to a single destination device. Also, we have broadcast MAC address. An Ethernet broadcast frame is received and processed by every device on the internet LAN. The features of the Ethernet broadcast are that it has a destination MAC address of 48 ones in binary, It is also flattened out all Ethernet switch ports except the incoming port. It is not forwarded by any router. So the MAC address table, the Ethernet switch examines its MAC address table to make a forward decision for each frame, unlike legacy Ethernet hubs that repeat bits out all ports except an incoming port. So the 4-port switch was just powered on, and the table shows that the MAC address table, which has not yet learned the MAC addresses for the 4 attached PCs. So first, examine the source of the MAC address. Every frame that enters a switch is checked for new information to learn. It does this by examining the source MAC address of the frame and the port number where the frame entered the switch. So if this source MAC address doesn't exist, it is added to the table along with the incoming port number. And then find the destination MAC address. If the destination MAC address is unicast address, the switches will look for a match between the destination MAC address of the frame and the entry in the MAC address table. So switch speeds and forwarding methods. So switches are used one of the following forwarding methods for switching data between network ports, which are store and forward switching and cut-through switching. So store and forward switching is a frame forwarding method. Receives the entire frame and computes the CRC. CRC uses a mathematical formula based on the number of bits in the frame to determine whether the received frame has an error or not. Cut-through switching is a frame forwarding method towards the frame to a frame before it is entirely received. So at a minimum, the destination address of the frame must be read before the frame can be forwarded. So a big advantage of the storing forward switching is that it determines if a frame has errors, and before propagating the frame, when an error is detected in a frame, the switch discards the frame. So discarded frames with errors reduce the amount of bandwidth consumed by corrupt data. So but there are two variants of cut-through switching, which is fast-forward switching and fragment-free switching. Fast-forward switching offers lowest level of latency, whereas fragment-free switching stores the first 64 bytes of the frame before forwarding. So that's it for this. We covered all the 7 modules in this defense, and that's it. Thank you.